Pre-Calculus. Today we'll be going over the quadratic equation, so I hope you have your handouts printed off, or if you're writing along with using a tablet, have that ready to go. This being the second handout, I want to really reemphasize that it is very important that you follow along with your own handout and fill it out as we're discussing this. Alright, so with that said, let's go ahead and continue. We will be discussing the quadratic equation, which looks like this. ax squared plus bx plus c, and this equals 0. And we'll go on to more where that's multiple variables, but for right now, the only variable we'll be using will be x. So note, when we look at these, we've got these letters, A, B, and C. These letters, A, B, and C, are all numbers. They can be any type of numbers. They can be natural numbers. They can be any integer. They could be any rational number. They could even be irrational or complex. We will be limiting our scope to simply numbers that are real and not complex for here. In terms of A, B, and C, that is. We might have some solutions to x that have a complex imaginary component, but A, B, and C, as far as this class is concerned, will always be real numbers. So let's get into how to solve a problem of this type. We've already looked at linear equations in one variable. Now let's look at the quadratic equation. I want you to notice one other thing. Where with the linear equation, we only had a power of 1 on the x, right? There's always an implied 1 right there. So x to the first power. Now we've got another one, x to the second power. So that's something to keep in mind. All quadratic equations will involve an x to the second power. Alright, so let's consider this first equation right here, or problem should I say. 5x squared plus 18x plus 9 equals 0. And so we're going to find two different solutions, because all quadratic equations will have two solutions. Now it could be the same number repeated, or it could be two completely different numbers. And so what we're going to do here is employ a strategy. This is called factoring. And here we're going to look at the first number, the A and the C right there. And note over here, we're going to be multiplying those two letters together right here. And so we see we have a 5 times 9, which of course is 45. Okay, so we've got our number 45, that's 5 times 9, that's the A times the C. So we want to list something called the factored pairs. Now what are the factored pairs? It's all the different ways we can multiply A and C together and get 45. So, the most obvious one is the one that we just did, 5 times 9, right? 5 times 9, well, that's 45. And another one that we could list is 15 times 3, and 15 times 3 is also 45. And then there's one that's even more obvious than all the others, and that is 45 times 1 equals 45. And I hope that is obvious. So what we're going to do is we're going to try and figure out when we add these two cofactors together, which ones will get us 18, right? Which ones get us that middle number, that B number there. So that's what we're after. So let's go ahead and take a look at this guy right here. We're trying to find 45, so let's go ahead and write some of them down. So we've got 5 plus 9. Well, 5 plus 9, what is that? Well, that's 14. Not what we're looking for, because that does not equal, and see what was B again? 18. Does not equal 18. All right, so let's go ahead and skip over to 45 and 1. 45 plus 1 is 46, and that does not equal 18. So that one also is out. Now let's look at the remaining one, the one that we haven't looked at, 15 times 3. So we go, okay, well, if we add them together, what do we get? We get 18. And that does equal the number we're looking for, B. So that's what we're looking for. That's what we want. All right, so we're going to go ahead and rewrite this whole thing. Let's go ahead and restate the problem. We have 5x squared plus 18x plus 9 equals 0. Now what we're going to do is we're going to break that 18x up. All right, we have 18x here. We want to break that up. We want to write that as 15x plus 3x, because note that does equal 18x if we add them together. So we've got 5x squared plus 15x plus 3x plus 9 equals 0. And so let me go ahead and highlight to make this obvious. You know, the two terms you see in blue right there are equivalent. 15x plus 3x is indeed 18x. And because 15 times 3 is 45, we're guaranteed to have a factored solution. So in order to factor this, first thing we're going to do is we're going to erect some parentheses here and there. If you wrote a 3x right here and 15x here, if you swapped them, you'll get the right answer. You don't have to worry about putting them in any kind of specific order or anything like that. If you flipped them, you will arrive at the right answer. The factoring may look a little bit different, but it'll still get you a correct answer. So you do not have to worry about getting them in the correct order. All right, so first thing we're going to do is we're going to take a look at this term here, and we're going to ask ourselves, what can we factor? It should be pretty clear. We can factor an x out of each one of those, and note that I can factor a 5 out of here and a 5 out of here. So we will be factoring 5x out of that term there. And so let's go ahead and do that. So we'll write an x here, because note 5x times x gets us 5x squared. And then plus 3, because 5x times 3 is in fact 15x. Okay. All right, so the next one. Note here that we can factor out a 3 from both of those terms. So we put our 3 there. And so we have x plus 3 and then all equals 0. And so note what we have x plus 3, x plus 3. How about that? We've got the same quantity in both parts. Now we can factor out an x plus 3 from this, and the reason that we knew that we were going to get the same thing in both parts is because we did all of our work over here to arrive at this guy right there as the proper way to break up 18x in order to make everything work. All right. And so we have 5x plus 3, and we're going to factor out an x plus 3 from both terms. And so we have, let's go ahead and use that one. Okay. Equals 0. All right, so nice. So now we want to find the two different solutions. We're going to use something called the zero product rule, just a fancy way of saying that we are going to look at this guy here and figure out what value of x will make it 0. Because keep in mind, if this is 0, you know, you're plugging in a number for x right here. And if this whole thing becomes 0, you know, this might be some other number. In fact, it will be another number. But 0 times any number is what? That's right. It's 0. And then we'll do the same thing, and we'll try and figure out what will make this 0 here, obviously negative 3. But when you plug in negative 3 for x, you know, this whole thing will become 0, and you've got some number times 0, which of course is just 0. Alright, so let's go ahead and solve these one by one using that. So we have x equals, so right here, note that it's going to have to be negative 3/5. And then we already said negative 3. And there we are, that's it. That is our answer. If you could not get this first answer here quite so fast, what you can always do, which is do a little scratch work, you do 5x plus 3 and you set that equal to 0, and then you solve for x. And when you do that, you'll find that, you know, subtract the 3 from both sides, divide by 5, and that's how you get negative 3/5. But when you've done it enough times, you can kind of just jump straight to it, because it'll become second nature after a point. But when you're still learning, if this negative 3/5 isn't obvious, just do this scratch work and it'll work out. Okay, so that is factoring. Let's go ahead and look at these next set of examples. What I very strongly recommend is pressing the pause button and try and work each one, like work number 1 and then see my solution, work number 2 and then see my solution. So that way you've got some more familiarity when you hear me speaking on the problem. So with that being said, pause and hit number 1 right now, and then I'm going to start. Okay. Hopefully you all realize that you need to press the resume button. So let's go ahead and look at this. We've got a negative 5 here. We want that over here so that we can just solve this simply. And this is going to be x squared equals 5. Take the square root of both sides, and we find that x equals the square root of 5. I should say positive or negative 5. So we have two different solutions. What that positive negative, you know, implies two different numbers. Let's go ahead and write them out so we can kind of see it. Like so. So those two answers are equivalent, of course. Note that 5 is a prime number. If you take the square root of a prime number, you cannot break it down any further. And so this is just how it is. I cannot relate the square root of 5 as the ratio of any two integers. And so the question of which number set does the solution belong to? Well, these would belong to the set of irrational numbers. Irrational numbers. Okay. Remember that fancy Q with the little squiggly there indicates that we're dealing with irrational numbers. If you don't have that squiggly, you've got a rational number set. All right, let's look at the next one. X squared plus 4. Same procedure. X squared equals negative 4. Take the square root of both sides, and you get just positive or negative 2? No. Positive or negative 2 times I, where I, of course, is the imaginary number, making this a part of the complex number set, but nothing else. Okay, and note that if you were to graph this on the complex plane, where you've got the real numbers and the imaginary numbers, and keep in mind this is different than an XY plane, because we're plotting a single number, not an ordered set. And so you'd go, you know, up 2 and then down 2, and those are your two numbers on your solution. And note how it's right about the real number 0 on this plane. Okay. So this next one, we're going to go ahead and use the factoring method that we learned about before. We're going to get some good practice in this one. So first thing we do is we're going to multiply A and C right there, just like we did before. A times C is going to be, go ahead and include that negative in the highlight. There we go. Negative 18. And then we're going to break that down. And keep in mind, what we want to find is the combination of numbers that when multiplied gets negative 18, but when added gets 7. So let's start with a few. Let's start with the most obvious one. 18 times negative 1. Note that I'm putting the negative on the lower number, since when they're added together it's got to be a positive number, but when you do this you get 17, which is not what we're looking for. Another set could be, or is, 9 times negative 2. 9 times negative 2 is negative 18. And when I add these two numbers together, 9 minus 2, I get 7, which is precisely what we are looking for. So, let's go ahead and work this now. And so we've got 6x plus 9x minus 2x minus 3. And so once again, note that is the same as the 7x that we have over here. We raise our parentheses. And note, you're going to have to be careful on this point, because if I leave this like this, I will have been making a grievous mistake. Let's zoom in here. And that being, note that I raised parentheses. Well, now that means that this negative sign that we have here needs to be distributed to both of these numbers, and that's not what we want. So what we're going to do is we're going to make this all right by, I think I need to move this over, make it a little bit easier for us. There we go. Bring those parentheses back. And so we're going to change this to make this correct. So this is going to be plus. Note that was always a negative. And now this, and we still want this to be a minus 3, so there we go. Take a moment, make sure that makes sense. Make sure that when you work through that, you note that you still get the minus 3, which is what you want over here. Alright, so let's go ahead and do this thing. What can we factor out of the first one? Well, it looks like we can factor out a 3x. Don't forget that square there. So we've got a 3x times 2x plus 3. And so now if you multiply this through, you get the same numbers back. 3x times 2x, well, that is 6x squared. 3x times 3 is, in fact, 9x. Good. All right, so let's keep going. Let's go ahead and switch these out. There we go. So plus, this first one doesn't look like anything cancels out. So we've got, except a negative 1. So let's bring out that negative 1. And so we have negative 2x plus 3 equals 0. Alright, so yeah. So in this one, we made sure that we took special care up here, but then we ended up switching back. Stuff like that happens. It's not a problem. Alright, so note once again, same number there and there, so we can go ahead and factor them out. I'm going to go ahead and put that 1 there so it's very plain what's going on. And so we have 3x minus 1 times 2x plus 3. And that all equals 0. Great. So let's go ahead and solve this guy for 0. What do I have to do to make that 0? Well, clearly 1 divided by 3 to make this first one a positive 1. So 1 minus 1 is 0. Right here we have 2x plus 3. And so for that one, 2 in the bottom, 3 in the top, they want a negative so that it counteracts the 3 over here. there we are. We have two rational numbers for our solution. Both rational numbers. Awesome. Okay. And so let's go on to number 4. Go ahead and shrink this down one more time. (2x² minus x minus 15). So first thing we do, a times c. Right, here's the a, there's the c. So we got -30. So now let's find the rational pairs. Okay. All right. And we have 15 times 2, and ultimately it's going to be a negative number, so we put the negative number on the higher number, add those together, we get -13. That is not what we want, because that does not equal -1. Right? So -1 is what we're looking for. Alright, so let's think a little bit more. Another one that we have is 6 times 5. We got -6 times +5. We add those together. What do you get? -1. That's what we're looking for. Good. Let's go ahead and work this one through then. We've got 2x² minus 6x plus 5x minus 15 equals 0. Okay. Raise our parentheses. And then we factor through like we did before. We've got a 2x in the first one, giving us x minus 3. And then on the next one, we can factor out a 5, and so again we've got x minus 3, that equals 0, and as expected we have the same number here and here, so we can go ahead and work this through. 2x plus 5, and then x minus 3. Of course, that all equals 0. Alright, and now we just solve each one for 0. First one, -5/2. Second one, simply +3. There we go. These are both rational numbers. Note that the second number, the 3, is both an integer and a natural number. Alright. So go ahead and hit the pause button, review this part of the handout, make sure it makes sense before we move on to the next part, completing the square.